Here we go.
All right. Well, welcome everybody to the Power Lunch. I see some trusted old faces and a lot of new faces as well. So, welcome to the chaos that we call the Power Lunch. A little bit about the format. We like to explore technology and technology topics. It's not intended to be necessarily a sales thing, but we want to expose people to new and exciting technologies. And StorOne is definitely one of those that we want to let people see. It's meant to be relatively informal, so if you have questions, feel free to ask. I guess we want to have you know allow the presenter to present, but if you have questions, feel free to put it in the chat, and share your thoughts. And at the end of the presentation, Jeff will have time for us to ask questions. So in there, the format is we try to get it into 40-45 minutes ish time, and then at the end we like to enjoy what I affectionately call the wheel of death, but I've been told that that's too negative, so we call it the wheel of fun and happiness, and we draw for a couple of prizes. So with that said, today we have Jeff Lamothe from StorOne. Jeff, why don't you start off? Tell us a little bit. It's a high level of who you are and maybe a little bit about your journey. How you got to where you are, and then dive into the presentation about StorOne and kind of the information there.
Sounds great. Thank you. Thank you for hosting me as well, by the way. So my name is Jeff Lamothe. I'm the Chief Product Evangelist / Product Strategist here at StorOne. My background is 30 years of IT experience, combined mostly around data protection. I worked in data storage companies such as EMC, Dell Compellent, Pillar Data Systems, Pure Storage, those kinds of storage systems. I've invented technologies in the past for those companies. And, I've also done a lot of work around cybersecurity. I hold a certified ethical hacker certification, as well as Security Plus, and have spent about good 10 or 15 years around the cybersecurity world, and bringing those skill sets together with my knowledge, kind of with the knowledge of data protection and storage management, storage systems, data migrations, all those kinds of things. Brings this consolidation type of training material that I'm going to present today. But that's my background. I'm fairly technical, so if you have any particular questions, don't hesitate to ask those questions. If you want to go technically down a rabbit hole, I can go down that path with you, or at least entertain those questions. But if it's also high level or business level related, let me know what those are as well. So this is pretty much my background.
Cool. Yeah, everybody feel free to ask questions. Like I said, I'll be monitoring chat. So if you want to throw it in there, I can jump in and ask Jeff the question. The other quick reminder is Amazon Prime Day. Make sure you're checking it out. Maybe we'll have a little section at the end about cool Amazon Prime Day purchases. But anyway, go ahead, Jeff. Thank you very much for that overview, and let's get into her.
Great, excellent. So basically, here at StorOne, not going to be a big presentation around sales, but I just want to talk about the technology, talk about some of the things to consider if you're looking at, wanting to maybe consolidate some workloads or consolidate different storage platforms. There's some things to consider. So I want to put together a few little slides about that and have a conversation about it. But what we think at StorOne is we think about results, and what we're always trying to do is solve the problem that the customer may have. And we also believe that storage is costing way too much money. I've been in the storage industry for 20 plus years, and it just gets more expensive over time, even though drive costs and other technology costs seem to be going down. But the complexity of the systems and the skill sets to manage the software, all of those kinds of things, the features, they all get added on, and it's starting to cost a lot of money. And it's always cost a lot of money to store your data. It just depends on the platform that you're with and the features and functionality that you get. Some have better than others. Some provide other features that some don't, and those kinds of things. So the other thing that we are seeing in the marketplace is storage is starting to become too complex. And that's because we have a lot of different protocols. There's, block level protocols. There's, iSCSI, fiber channel, NVMe over fabric, NVMe over TCP/IP. Then you have your file type of protocols, your NFS, your NAS, your SMB shares. And of course, then you have your object storage and all those different protocols either provide complexity with what products to get, or complexity with how do I manage multiple products or multiple solutions that are maybe point-based that only offer some of those types of protocols. And so what we try to do is we want to look at how can we make things more simplified in the future. Also, what we're seeing in the marketplace is that storage is too vulnerable. Hardware failures are one of the main reasons for data loss. And also, even if you don't have hardware failures, you have disk drives that last a long time. You could actually have bit rot. We've seen some of that. And then, of course, you got the malicious actors these days, the ransomware, viruses and data corruption, data encryption, all those kinds of things actually can cause either accidental encryption, accidental deletion, or even on-purpose malicious type of activities such as those. And so what we have to find is, since the storage system is where the data lives, how can we protect against these kinds of malicious activities? And then, of course, what we're also seeing in the marketplace is that storage life should be measured in decades, not just 3 years or 5 years. There's disk drives that are still out and available, for a long time, and been around for a while. They're still good, right? So you can still be used. But at the same time, there's a lot of different storage manufacturers that will say, every 3 to 5 years, you have to replace your technology. And the reason why that is because maybe they have new features or new technology, hardware technologies come out, like faster NVMe drives or faster network cards, or faster CPUs, or faster, more dense memory, more dense, hard drives, or more dense SSD drives. But you can't put those into, that new technology into those systems because of various limitations, or their code's not ready for it yet, or those kinds of things. So, they force you into a life cycle so that every 3 to 5 years you can be upgraded and stay within the journey of that particular platform and take advantage of new hardware as it becomes available, or as they make it available to you. So there's 5 degrees of storage complexity, and these kinds of things are really what drive the decision to say, should we consider replacing our storage system or consolidating our storage platforms that we might have? So from these particular degrees of storage complexity, one is around costs. Sometimes those are costs around just the product. The maintenance might be costing you more money than it could cost to buy a brand new system. That's one example. Or the cost of rack space and power and cooling, or the cost of growing the storage platform, or the cost of moving to a new platform might just be too much money. So there's costs that you have to look at. But then there's data resiliency. If you're looking at a new platform, or you're looking to do consolidation, you want to make sure that whatever platform you look at has one of the top rated data resiliency. It has the ability to recover data very quickly from a hard drive or hardware or SSD failure. It has the ability to recover data quickly in the event that you have a ransomware attack. Can you protect your data at every 60-second intervals and recover from that? Because the latest version of Rorschach ransomware can actually encrypt 20 terabytes of data in less than an hour. So that's a lot of data to encrypt. And if you have a very fast system, I can actually encrypt it much faster than that. So from that perspective, can you recover just as quickly? What we're finding is that becomes a problem. And then, of course, refreshes. Can I refresh the hardware in my storage system I have today by pulling out one disk drive and putting in a brand new one that might be 2 times or 3 times or 4 or 5 times X the capacity without having to have performance degradations? Could I upgrade my controllers? Can I upgrade my cards with no downtime? Could I refresh the technology in the same platform? Or do I need to do a data migration those refreshes, those data migrations, they're an impact to the business to some degree. Even if they can be done with no downtime, there is some impact because it takes people, it takes resources, it takes time, it takes planning, it takes effort to do those things to make sure that it does go off without a hitch so that your applications don't suffer any kind of downtime. And of course, then there's operations, especially if you're looking at a brand new system. Some of the operations that care and manage and feed the current technology that you might have, it might take a little bit of a learning curve to learn something new, or it might take a little bit of extra, extra time to learn, the operations of the CLI, API, the REST, or just the GUI. So there's a lot of different things in operations. So I guess there's some feedback if you're not on mute. Could you put yourself on mute? So also in operations, there's integrations. A lot of people don't think about, hey, you know what, I'm going to replace my current system, and I might be using some monitoring systems or maybe some graphic data reporting systems. And they've done some custom work or some integration work that has been taking place that allows the business to have insights into their current technology. Doesn't matter if it's a server or storage or network or whatever it might be. You got to look at the impact of, if I replace this piece of technology, how can I replace it and get the same functionality or the same reporting, integrate with the same tools that I have today that the business might rely on? So you have to make sure that the operations, also integrations, work very seamlessly as well. So there's a lot of things to consider from that perspective. And then, of course, there's the lack of storage platforms, or what we now call silos. There's unified systems have come out for the last, 5 to 8 years or so, but they really are unified mostly around file, around block and file, or unified around file and object, so how do you get the ability to have all of those different types of protocols, as well as all the different types of media that you might have, from NVMe to SSD, eMLC, TLC, QLC, all kinds of different SSDs, and then you got your hard drives. People still use hard drives today. So there's those kinds of media types that you might want to have, and you might be able to say, can I consolidate all this stuff to make it more simplistic? So then there's 5 things to consider for consolidation. And these are things that, once I've made the decision that, this technology I'm on does cost a little bit more money, it is complex, it meets those 5 degrees of complexity, and you want to kind of make your environment a lot more simplified, then you got to go through this type of consideration for the consolidation, and that is workload analysis. We're going to talk into a little bit about what that means, scalability and flexibility, compatibility and integration, data migration. What kind of data migration do I have to deal with? What kind of impact do I have? Does it make sense to spend the money on that, or, the resources to do that? Data protection and security is the biggest one, because without the data and without the protection of that data, most businesses will struggle to survive, if they lose their data. So that's very important. And, even in ransomware, I do a lot of ransomware workshops, and I get a lot of questions like, hey, I have all these different kinds of security tools, firewalls, and I got EDRs and XDRs, and I have all kinds of, front-end defenses, right? But I always ask the question, so how are you protecting your data in the storage array? Are you protecting your data, your backups? They're like, what do you mean protecting backups? Do we make backups of backups? I'm like, yeah. Do you protect your backup systems? The answer is inevitably no, they don't. The reason why is because, well, that's a secondary copy. It's a backup copy. Hopefully I never have to use it. But in the event of a ransomware attack, they find out that they do have to go to the backup systems. And then when they do, they find out that they haven't done their due diligence in testing their backups for many months or many years. And then they also find out, oh, crap, my backup systems are encrypted. All the data is there is encrypted. So I can't recover from my backup system. So I asked the question, can you recover from snapshots? They're like, oh, yeah, our storage system has snapshots, but we only do snapshots once or twice a day. I'm like, all right, well, that's great. At least you can recover from that point in time, until they find out that they go to their storage system and find out their snapshots have been deleted as well. These are real live examples of people that have come to me over the last 3 or 4 months and said, we've lost our backups, we've lost our snapshots. They deleted our snapshot schedules, and then they deleted our primary data or encrypted the primary data. And so now we have to pay the ransom, because we don't have all these other mechanisms in place for data protection and security. So you can have the best front end defenses, but if something gets in through the front end defense or some comes in through the back door and it attacks your data where the data lives, that's where we're finding no one is really quite prepared for the ramifications of what they find themselves in at that point. So I want to make these things known to people and give some education about these kinds of concepts and these kinds of considerations to think about, even if it's just to improve your current environment with whatever you might have today from a technology perspective. There's a lot of new features and technologies that will be available to you. Sometimes that means you have to either upgrade to the new feature or maybe just upgrade to the new operating system version or code, or maybe even upgrade to the new version of that platform hardware wise. But in that case, there's no matter what, you have to go through these kinds of processes. And so one of the processes that we want to talk about is workload analysis. And that's really around assessing the diverse workloads in your storage requirements, looking at your protocols, your block, your NAS, your SAN, your object, looking at the commonalities between those different systems and the data. How old is the data? That's another concept that a lot of people kind of look over. They're like, oh, we're just keeping the data on the system forever and ever and ever. But it's in the same volumes, it's in the same, high expensive storage platform or in this high storage media type that all your other data is in that's most frequently used. And so, that makes it vulnerable to attack because it's still there in the primary volume, but also it's more expensive for you to keep it there because it's not being used, it's old, but, it's part of the volume. So what do you do with it, right? I can't move it around, or else I impact my performance, which is the next one, is document your performance and capacity utilization from each of your storage systems. Take note of the number of drive types and existing storage systems that you have, because the reason I say that from a hardware inventory perspective is because what you'll find a little bit later in our presentation is we're hardware agnostic. We can actually take hardware from any other type of storage type and manage it and make a brand new storage platform out of the hardware. So we're hardware agnostic. So we'll get into that in a minute. But if you take note of the number of drive types that you have and the existing storage systems, that gives you some math that you can do. You can calculate the number of IOs that you can potentially get out of that system that you might not be getting today, or you might not be able to achieve. Or you're just not pushing it hard enough. So that means I could probably buy something less or buy something with the same number of or the same type of drives that I might currently already have, as well as those drive types also have a capacity associated with them. And so that gives you the ability to say, well, if I'm at 3.84 terabyte SSDs, maybe I can get with 7.86 on my next upgrade or 15.36 on my next upgrade and double or triple the capacity. And just doing this upgrade at the same time. So looking at those utilizations, looking at those workloads, those metrics in your existing storage platforms or your existing applications that are attached to those platforms can give you some really good insights as to, could I really consolidate all of these different things together, or do they really have to live separately if they are living separately today? So when we look at the next one, which is scalability and flexibility, we need to evaluate the scalability and flexibility of the storage consolidation solution that you're looking at. Whether that's bringing in a brand new protocol into your current storage platform, could that storage platform handle it, or is that feature version 1 of that company, and you might impact your current performance, or you might impact your block level applications in that way, or vice versa. Those kinds of things. Considering the support and various protocols is what you really want to look at here, is because the future, you never know what you're going to need in the future. I was talking to some folks today earlier, and they're like, we have a lot of AI requirements now. AI is the big thing, and we don't really know what that means, but we know that we might need, some S3 object storage. We also need some NAS storage to share across the AI nodes in the cluster. And we also need very fast, high performance ingest media that has the ability to do millions of IOPS so that we can have real-time responses. What kind of storage system should I buy? That's a good question. What kind of storage systems do you have today? And could they take on those kinds of capabilities and protocols? The answer might be yes. The answer might be no. So what you have to do is you have to evaluate what you currently have and can it take on those different protocols and those requirements. And what you really are looking for in the future, if you're going to replace what you currently have, look at something that can handle all the protocols and all the media types in the future so that you can have the capability of adding on new workloads as the business demands it without having to spend a ton of money in technology. And so since storage is a very large portion of IT spend in most cases, this can be a very, very valuable area to analyze in your environment to determine, is my current systems flexible and scalable enough for the future? And of course, then there's compatibility and integration. This one kind of goes overlooked a lot of times. A lot of people like the newest features or the newest version of something or the newest company that's out there that says, what, this can really save me a ton of money. It's going to make my life simpler. It's going to take away all this pain points that we talked about. But it doesn't integrate with my current monitoring system tools, my current NOC or my current SOC tools, whatever it is that you might really rely on. Just kind of work with that manufacturer to say, hey, can you help me get integrated into my current tool sets? Because maybe they don't do it today, or maybe they just haven't tried it. But you'll find out by asking those questions, either is that company willing to help you integrate into those tool sets, or have they already done so and have some documentation that you can use to integrate your environment? And if not, then is it really, even though it can solve all those problems, but you can't get any insights to it, you can't use your other tool sets, or it doesn't integrate to those tool sets, is it worth it from a business perspective? So you might need to do that kind of analysis as well from a compatibility and integration perspective. And then of course, the other thing around compatibility is operating systems. There's a lot of times that, systems are out there, operating systems are a little bit older. People are running older operating systems because of applications are tied to specific libraries, tied to specific versions of operating systems. So it's not so easy just to upgrade the operating system. So sometimes a brand new storage platform can't connect to an old operating system. There's differences in the way that the code has been written, the differences in the way the block sizes are presented. Those kinds of things are starting to occur in newer technologies. So you want to ask those questions. Can I seamlessly integrate all of my applications, all of my operating systems into the existing or the new platform that I'm going to look at, consolidating everything into or replacing what I currently have? Data migration is the big one. Now that you've made all these analysis points and you say, what, we can save a ton of time, we can save a ton of complexity, make things more simple, we can do all these things, it integrates well, it's compatible, let's do it, let's pull the trigger. And then we find out, well, doing that means that our business is going to be impacted because of data migrations. It's going to take a long time to get to that platform. I was doing one storage product for a very large financial institution when I was at Pure Storage, and they were very excited about getting off of Hitachi storage. And it was multiple petabytes in multiple data centers across the country. And we had thousands of servers. And what they found was they said, hey, this is great. Pure Storage is fast. It's more affordable. It's got all these dedupe and compression. It's great. And then we found out that it's going to take 3 years to do the data migration, and that they bought a 3-year contract for the hardware. So they're like, by the time we migrate to it, it's already end of life, or we already have to renew the contract. So that's what I mean about data migrations. It might be worth the while to do it, but is it going to be feasible for you to migrate all that data? And some companies have it easier than others. Some people are using technologies like VMware or Hyper-V that can make things transparent, easy to migrate, but there's still some process. There's some time and resources, and there is some performance impact to their application on the current storage platform while you do those operations. So I would ensure that you can plan out your data migration, or at least have also budget for it. If you might need tools, you might need to migrate data with certain tool sets. You might need to bring in some people to help you to consolidate the timeline of data migration to get the most out of the new hardware or the most out of the new system that you're looking to put in. All those kinds of things could really become a factor. So a lot of people kind of overlook this. They're like, oh, well, I solved all my problems. It's someone else's problem to now utilize the system. But in order to utilize it, I got to move data to it. I got to migrate it. And that can cause a business ripple impact down the road. And then the last one here is data protection and security. So what we want to really look at is prioritizing data protection, security, and the store's consolidation strategy. Make that part of, that should be the main theme is to whatever technology you're looking at, whether you got your current technology, you're asking yourself, how can I use my current technology to improve my data protection? How can I improve my security posture? How can I improve the RPO and RTO values of recovering data? How can I help mitigate the risks against a ransomware attack? What if we can recover data quicker? Would that make a big difference? Is that a need? Also look at your insurance policies. A lot of people are looking at getting cybersecurity insurance, and there's a section in the cybersecurity policy application form that asks you very specific questions around your storage environment, as well as your backup policies and procedures and your backup technologies. And based on the wrong answers, you can either get denied for your insurance, or you can have such a high premium because you don't have a lot of current technologies in place to reduce your risks or to recover data in a quicker time frame than the insurance companies might like. So depending upon your business and what you do and the importance of the data, the criticality, you could find yourself having to pay a lot of money for cybersecurity insurance. And I've seen that over the last few months as well. And so you also have to ensure that the solution provides robust data protection mechanisms, such as encryption. Can I encrypt the data at rest on the drives? Can I use SED drives, self-encrypted drives? Or can I also have encrypted volumes? Could I use both, encrypted volumes and encrypted drives? There's a lot of push now to putting encryption at the application or at the database layer. Could my storage system currently handle that? I look at, when I was at Pure Storage, a lot of people were putting in database encryption, and then all of a sudden the dedupe ratio would go from 8-to-1 to 0. And they were like, hey, our Pure Storage has now gotten much more expensive because we don't get a dedupe ratio. We have to buy a whole lot more capacity. So does it make sense to do this? And we had to go back and tell the customer, well, don't turn on encryption at the database layer. You don't need it. We have it on the system. But they're like, but our insurance company's telling us we have to do it. So what do you do, right? So you have to look at something new or something that's less expensive that gives you the same performance levels, the same SLA levels, the same data protection levels as what Pure would give. It's a good product, don't get me wrong, but in certain environments, it's just not the right product for the data set. And so with that in mind, you got to keep, take a look at what your data set is, what your requirements are for that data set and the protection policy around it, because that could dictate what storage systems you might have on your list of potential candidates to replace your current technology with.
Hey, Jeff.
And so, yes.
Quick question for you from the group here. Someone is wondering, when a company or a business pays a ransom, how often do they get their data back? Do you have any sense of that? Just anecdotally. I do have some statistics on that, since I do a lot of ransomware workshops. And if you're interested in doing one of those, let NetV Pro know, and we can sponsor one at no cost to you. But to answer your question, definitely. So of people who got hit with ransom and that paid the ransom, and I know of quite a few companies that have, only 4% got all of their data back. 4% got all of their data back. 4%. 4% got all of their data back. 69% got some of their data back or most of their data back, but not all of it. And the reason that is if you look at some really sophisticated ransomware, like Play Ransomware encrypts every single file with a different encryption key, and they don't do a very good job of keeping the key value pairs of the file that you have and the encryption key used for that specific file. And what makes it even worse, and I've demonstrated this with my own ransomware that I wrote that works off of that Play Ransomware concept, is
that if you have the same file name in two different directories, they're definitely different files, but it's the same name, which allows you to do in two different directories, then they only keep track of the last file. They only keep track of file names, not the complete path to the file name. So there's a lot of mishandling of metadata and other data bits that a lot of ransomware people, they don't take into account for. So that makes it harder. Even if you pay the ransom and get the encryption keys back, you might not get back all your data for those reasons.
You'd think the bad guys would offer a better warranty on that.
Yeah, because their whole thing is to get paid, right? And that's why they do all of this work. You know, there's ransomware as a service. There's all kinds of things that are out there. There's ransomware as a service groups that run 24/7 NOCs of thousands of technology people in their SOCs and NOCs. And they basically, their job is to, once they get a foothold into an organization, their job is to expand it. And so they can be in your network environment for up to 227 days or more, getting all kinds of access to systems and mapping out your network. They'll probably know your network traffic and net flow better than you do. The next thing you know, when they launch their attack, you know, their whole thing is, hey, well, we're going to launch the attack from multiple different angles so that we can get a high value data, number one, but also make it very possible to get paid the ransom. And then they also work with ransomware brokers that say, well, you know what, hey, we're going to charge you $5 million for this ransom. You know, some people have paid up to $600 million in ransom costs. I had one customer about 4 months ago who I gave a ransomware workshop to. They were a healthcare organization. They got hit with ransomware. They found out about it on Monday. They found out that their backups were available. So they did some restores, but they didn't get to restore all their data. They had some failed backup jobs. So some of their critical systems they had to pay the ransom for. They paid the ransom and they were able to get their data back. And which is great. They were back in business by Wednesday or Thursday. Granted, this was down on Monday. So by about 3 or 4 days, they got their data back up and running. All their systems are good. And then the next weekend, they got hit again.
Oh, geez.
And they got hit again. The reason they got hit again the second weekend is because they recovered the ransomware in the recovery of their backups. It was already in their backups. So they've been backing up this ransomware on their systems for months. And so when they do the restore, they restore the ransomware back to the systems. And then it launches a logic bomb and it starts again. And so Saturday through the weekend, they encrypted their data again. Monday, they found out encrypted. They didn't have time to fix their backup faux pas and misconfigurations. So they were stuck again without having data recovery capabilities 100%. They had to pay the ransom again.
Always good to avoid the self-screwing thing.
Yeah, and well, this happened 3 times in a row. 3 weekends in a row. So, and each ransom was over $1 million. So that's like $3 million out. And then they finally figured out, okay, let's spend some time to fix this. They got some resources in, they fixed that problem. And then about 5-6 weeks later, the bad guys called them up and said, hey, you know, that time when we encrypted all your data, we also stole it. So if you pay us another $3 million, we won't leak it to the dark web. So they ended up paying $6 million. And they asked me during my ransomware workshop, they said, how much would it have cost us to protect our backups with your system? And I said, well, give me some numbers. They gave me some numbers. And I said about $300,000, which is a lot of money. They had a lot of data. It's a very large environment. And they were like, well, that's a whole lot of money than the ransom we paid. Said, exactly. Look at your security potentials, look at your technology, look at the cost of improving that security posture, and look at the ransomware is usually $1 million and up. They don't usually start off with less than $1 million. And then of course, there's the after effect of a ransomware, the aftermath. Even if you pay the ransom and got all your data back, there's still a lot of other effects that you got to deal with that cost money or that could cost you your reputation. You might get hit with fines, you know, all kinds of other things could happen, even though you recovered your data. You know, so the whole idea is to try to recover it as quickly as possible, protect your data as best as you can, and have all the other security features in place to where you can mitigate the risks. It's kind of like what I say is if I'm a burglar, and I'm going to go look at the high-end homes where I live. You know, each one of those high-end neighborhoods have gated security with a security guard. I got to give my driver's license to them before I can even get in. Then they got to call the owner of the house to get in, to bless me in. And then when I get there, I see that there's alarm system signs on every single lawn. So everyone has an alarm system. I look at every house. They have external cameras. They have internal cameras. I'm like, you know what? If I want to break into this community, I'm going to be found out about it. There's something, I'm going to get caught. So I can go down the street, maybe 20 miles down the road, and find nice homes, but not as nice. But they don't have all the features. They don't have security gates. They don't have security alarms. Maybe their security alarms, they don't turn on. They leave the windows open at nighttime. There's all kinds of different things. I'm like, that's an easier neighborhood for me to hit, because they don't have all the tools, or they don't implement the tools properly. So I can go after that neighborhood and get a lot more loot for my effort, and hopefully not get caught. And that's the whole point around technology. They're looking at it. If it's too hard for them to get in, they're just going to go look elsewhere. They want the path of least resistance.
Mm-hmm. I have to imagine in that repeat offense scenario that there was some itchy C-level people who weren't very happy about things.
Yeah, the C-level people were actually the ones at my ransomware workshop. So
sure, right.
Those were the folks. And it was very enlightening to them what they learned. And they also learned that I showed them how they could actually utilize some freeware tools to analyze their encrypted files and actually get the encryption keys without having to pay the ransom. So there's a lot of things I can teach you from that perspective. And hopefully the goal is to educate you on all these different types of technologies, what you can do for free, but also what you can do at a low cost to make a big difference in your environment. So when we think about, moving forward a little bit, we think about, StorOne, and we talk about what we are and what we can provide. This goes into a little bit about what we do that's a little bit different from most of the other storage manufacturers out there, to go over those 5 degrees of complexity and those costs and those things to consider when you're looking at consolidating your platforms. We basically rewrote the entire IO stack, and it's in one storage engine. So we're a virtualized software-defined storage data platform. We are cloud ready. We work with MSPs. You can also buy our software and have an on-prem deployment, as well as you can have all the protocols. We support block, file, object, all the protocols. We support all the media types in the same platform. And as well, we have a complete virtualized capability of virtualizing all and abstracting all of the hardware layers of your controllers and all the storage and all the media and all the different storage pools. We have all kinds of innovations that virtualize it very similarly to what VMware has done for servers, or what SDN has done for networks. We're doing that for storage. And that gives us the ability to be very flexible, to become very efficient, and to have the most resilient and the best data protection mechanisms in our platform available to any storage manufacturer. And that gives us the ability to, when we can now support all the protocols, we can now run on cloud or on the prem. We can run with MSPs as partners. We can have a lot of different configuration types. We can also support all the stored media, and we have complete data resiliency and the best of breed data protection capabilities on the market in a storage platform, that is. Then that gives us the ability to now say, well, let's reach out a little bit further. And what are the use cases or applications you want to start with? What we find most attractive is the backup and archive, because as I mentioned, no one's taking snapshots of their backups. I'd be interested to see here if anyone is taking snapshots of their backups or is doing backups of their backups, right? And they might send their backups to another place, but if it gets encrypted before you send it off, then it's encrypted when it's sent off, so that really doesn't help you when you need to pull it back. So when you have the capabilities like we do of protecting your data every 60 seconds, and those backup data pools where you dump your data to from a backup like a Veeam backup or a Commvault or a Net backup or any of those kind of backup systems, we can be the backup target. Land the data on our platform, we snapshot it every 60 seconds, gives you that instant recovery. And we can also tier the data across different types of media types. And it doesn't matter the protocol that you want to back it up for. If you want us to be an S3 object and you want to sling data to us from that perspective, no problem. You want to provide a NAS front end to your, to your backup systems, no problem. We can do that. You want to be high speed fiber channel or iSCSI or NVMe over Fabric, no problem. We can connect that as well. Take in and ingest all that backup and archive data. But then, of course, when we have other use cases like databases and artificial intelligence and high performance computing and VMware and all those other kinds of things that you run your applications on, could you run those applications on our platform? The answer is yes. And you can run those because we support all the media types. We can support NVMe that gives you 1 million IOPS per drive. We can put 24 drives in there and get quite a bit of tens of millions of IOPS in only a handful of NVMe drives. If you need high performance. And then of course we have capability of putting in 30 terabyte SSD drives. And then you can tier your data between NVMe and SSD. So now you have a 7.86 terabyte NVMe drive, tearing it down to 30 terabyte SSD drives, and you still have an all-flash system. There's not very many people out there, even where I came from at Pure Storage. I have to buy a flash array X and I have to buy a flash array C in order to take my NVMe and my QLC flash drives. And then, of course, then there's no way to move only portions of the data from one system to the other. It's either all or nothing, right? So that's not what I want. I can't use that, but we provide that capability. So what our customers are seeing is they're seeing a very resilient, low-cost storage platform. We license based on the drive count, not based on the capacity. So that's a huge savings right there, where a lot of other storage systems, you got to figure out your effective capacity or raw capacity, and you're going to pay per gigabyte, per terabyte. We don't care the capacity that you put in it. We're going to say you want 20 drive slots, you pay us a license for 20 drive slots. That's it. The really cool thing is I can replace that 7.8 terabyte SSD drive with a 30 terabyte SSD drive in the same slot, one at a time, and not have to pay any more cost of storage other than just what it cost me to buy the drive, which you can buy the drive on your own. You don't have to buy it from us. You can buy it anywhere. So that's really cool. So what we're looking at here is we've introduced, and we're the first to come to market with the virtual storage container, or we'll call it VSC. And if you look at virtual machines, that's what VMware or hypervisors, Hyper-V and KVM and all those guys, the hypervisors, they did that for servers many decades ago. And then, of course, the last decade or so is software-defined networking, and that's what decoupled the management and the control planes from networks and made networking much more virtualized and affordable. And now what we're doing with our virtual storage container is the same thing. So we're completing the entire ecosystem or the virtualized storage messaging around virtualization. And so we have a couple of key innovations. One is a virtual storage container. And what that really means is that now, this is kind of like a volume for all you storage managers on the call. Every storage system, you're going to create a volume. That volume has to have a certain RAID level to it. It has to be on a certain media type, and you're going to serve it out over a certain type of protocol, right? So from that perspective, what our virtual storage container is basically a volume. However, it can live on any kind of media. It can actually live on multiple types of media. We have what's called virtual RAID, which is another innovation we'll get to. And it gives you the ability to say, I want this level of redundancy on this volume or this virtual storage container. I want this level of RPO and RTO. I want this type of data resiliency on this storage container. I want this kind of performance, and I want it to move automatically based on thresholds and real-time data algorithms from one tier storage to another, because I want to use my NVMe for very, very high, fast frequency of data, high frequency data. But once that data is in there and ages, I want it to automatically move to my 30 terabyte SSD drives, so I can have more data in my system at a less cost and still have great performance because it's all on flash. So then you have a cacherless architecture. And what we've seen in the legacy systems and even more modern systems of the last few years or so is cache is a bottleneck. Cache is a limitation. And that's the reason it is because cache is where we basically have all of our bitmaps and our data management, our metadata has to go to cache. Some data has to go to cache. And so from that perspective, you have to write there first, and then it gets written down to your flash media tier or your hard drive tier. And so with that, there's extra cost associated with those kinds of solutions: battery backed up cache, cache mirroring requirements, data integrity. What happens to the power? If I pull the power, I have to flush cache before I do snapshots. Then there's a limited number of snapshots I can have because I can only have so much metadata in my cache, because I have to have so much room for that cache to be used for other data purposes, data service purposes as well. So what we found is cache can be a bottleneck. And what we did when we rewrote the entire IO stack, we rewrote it without the need for cache. Now we can put NVMe or SSD drives in there for our metadata. And some would argue, well, isn't that cache? I'm like, well, that's flash. It is sort of a cache, but we're talking about cache that is direct versus cache that's non-volatile. And so from that perspective, we can write directly to the media. And when we do that, we can actually get better performance. So we can actually get 2 or 3x the performance of the same type of drives that are in other systems. And in fact, what we've done is we've taken some of our competitors' hardware, and we took some hardware from one competitor controller-wise, we took some hardware from another competitor disk-wise, and we put it together and we ran our software on it, and we got better performance and better utilization than those vendors got alone with their own systems. And so that kind of tells you that the bottlenecks are real, and what we've gotten in our what we've done in our innovation has gotten around those to give us much more better efficiencies. And then what we also have called is VRAID. And so VRAID is really based off of erasure coding, and we rewrote that. So it gives you the ability to say, I want a +1 or a +4 or anything in between that for a data durability perspective, which means I want my data to be striped across X number of drives and my parity to be striped across X number of other drives. And it gives me the ability to not have to have hot spares. It gives me the ability to replace a media type or drive size with a larger one without having to wait for the entire RAID set to be rebuilt or RAID set to be replaced. It gives us the ability to have mixed match drives. I can have some SSD drives that are 7 terabytes, some that are 15, some that are 30, all of the same type of storage type, like all QLC or all TLC, and we can actually stripe the data across all of those, because we look at the drives themselves and the free capacity on them, plus the RAID stripes. And we can actually recover, a 20 terabyte hard drive, very dense, extreme dense hard drive that's very, very slow at 7,200 RPM in less than 3 hours. Whereas most other storage manufacturers don't even want to put hard drives in their systems because they know it takes days, weeks, or even in some cases months to recover a 20 terabyte hard drive. And so that increases their rate of failure. So what they'll say is, well, we're flash only. That way we don't have to deal with slow hard drives. But there's a big benefit of having slow hard drives in certain workloads. So, if you can put them in and have a 3 hour or less time SLA to rebuild it, wouldn't that, be a better cost-effective way to manage your storage, as well as, get better durabilities out of your system and save some costs and efficiencies? And one of them, the other one is optimized data placement, or what we call ODP. ODP gives us the proactive data cascading placement capability, which means I can have some of my data be on NVMe, some of it be on QLC, some of it be on hard drives, and I can put thresholds to say when it gets to this type of age or this type of utilization or this type of performance on this volume, or lack of performance on that volume, start to migrate the data down or migrate the data back up and actively place it in the right media type of the right performance based on what I've set in my virtual storage container. And so we can actually be predictive and proactive, and we're very fast. We can move up to 700 terabytes a day in our optimized data placement. And that's with hard drives and flash. So from that perspective, we can move data down to hard drives 700 terabytes a day and bring it back up if it needs to come back up that fast. And then, of course, our last one is differentiated snapshots. But really, every storage system has snapshots. And if it doesn't, you really need to look at something else, because snapshots are what's going to save your bacon for an accidental deletion or accidental encryption or accidental whatever, but it's also going to save your bacon against ransomware and those kinds of things. Having the ability to recover that snapshot and not have to go rely on your backup system or move data across the network is going to be very much quicker than doing those other processes. But what we found in snapshots is that they rely on cache. So even the largest snapshot vendor I've seen out there allows you to have 50,000 snapshots per system. But they also allow you to have 10,000 volumes per system. So if you had 10,000 volumes and your limit's 50,000, that means you can only have 5 snapshots per volume. There's not a lot of people probably having 10,000 volumes in a storage system, but some do. So if that's the case, you really can only have 5 snapshots per volume before you reach your system limit. And so that means you can only take snapshots either once a day for 5 days or once an hour for 5 hours, and you're not even covering an 8-hour day. So how do you deal with my frequency of how frequent I can create snapshots and recover data from? What happens to my RTO and my RPO if I can't take snapshots frequently because I can't have as many of them? We have unlimited snapshots with no overhead, as well as they're complemented by replication, but they're not dependent on snapshots. So we can replicate data synchronously, asynchronously, or semi-sync from one to many or many to one locations without having to be dependent on a snapshot, meaning that we don't have to take a snapshot first and then replicate the data. So we can actually do that, in tandem, in parallel with snapshots, and have different schedules for that for your data protection requirements. So that's what really makes us different. And so if you really look at, well, do I really need another storage vendor? We're talking about consolidation. The answer is maybe one more could be the solution to your environment. Maybe that's StorOne, and the difference there is our flexibility, our lowest total cost of ownership, our data resiliency, and simplicity and transparency. And each one of those buckets, there's all kinds of different benefits that you would get from it. We can provide all the protocols. We can provide all the media. We can provide as much performance as you need. We can provide as much dense capacity. We can provide your data protection, both snapshots and replication. We can also run in the cloud. We can run on MSP hardware. We can run, on premise. We can actually take in all those different workloads from all those different siloed systems, and have a modern system that is future-proofed in the future. So in the event that you wanted to take advantage of a 30 terabyte NVMe drive that's not even out yet, but it might be out 3 years from now, when that drive comes out, all you got to do is go buy it. When you buy it, you slide it into our system and it's immediately available for you. Or, hey, I want to take advantage of a 250 gig network card, or whatever it is, well, it's not out yet, but when it comes out, all you got to do is put it into a PCI slot in the controller. Oh, by the way, you can have those controllers be Dell servers, HP servers, Lenovo servers, Supermicro servers, whatever server type you want. We'll help you size it, but it can be any of those servers, and you just put in those PCI cards for fiber channel, for iSCSI, networking, whatever speed you want. And oh, by the way, we virtualize all that. So those network ports that are maybe 100 gig or 200 gig can be virtualized to run S3. They can also run iSCSI. They can also run NFS, SMB, all on the same port if you have the bandwidth, or you can specify what port groups you want to have across cards. There are all kinds of things you can do. But the goal here is that whatever the technology is going to come in the future, our software is already built for it because we're software defined. We're not coupled with the hardware. You don't have to buy us as an appliance. We can sell it that way, but you don't have to buy it that way. You don't have to grow it or refresh it that way as well. That's pretty much the slide. I want to have a few minutes left over for some questions.
That was a lot, man. That's some cool stuff. Some very interesting things. Well, first of all, does anybody have any questions for Jeff? Make sure we get those out if you have any questions. Let me rephrase that. I'm sure people have questions. Anything you always want to ask Jeff right now? Hearing nothing. Let's Piper, let's quick go to the wheel of hope and good harmony and get that
adventure.
The wheel of fun and adventure and get that taken care of, the drawings for the Amazon cards. So we'll get that done, and then we can kind of pop back in there. Jeff, do you have any time to go past one, or do you have a hard stop at one?
I do have a hard stop. I could probably go an extra minute or two if I had to. I pretty much have a hard stop at the top of the hour.
All right.
Can you see my screen?
Sure can.
Yes.
Awesome. I figure with the amount of people we have, we are going to spin twice today. So we'll spin, take out the name, and then spin again. So for our first winner, which both will be $10 Amazon gift cards for Amazon Prime Day, I'm sure that would help. Oh, Joe.
Joe Monahan. Very good. Winner chicken dinner.
Mhm.
Good for you, Joe.
And
And number 2.
John Wesley.
John Wesley. Very good. So there's our winners. So we'll get those cards out to you.